Hello, grade 12s. Welcome back to the channel. In today's lesson, we're going to be looking at hyperbola functions, all the things that you need to know under the hyperbola functions. And then we have lesson objectives. By the end of the lesson, you should be able to determine the equation of the hyperbola. You should be able to determine the x and y intercept of the hyperbola function. You should be able to determine the equations of the asymptotes of the hyperbola function. And then you should be able to find the axis of symmetry with the positive and negative gradient, and also be able to discuss the domain and range of a hyperbola function. So without any further ado, let's just get right down to the business of the day. So, okay, when it comes to hyperbola functions, obviously there are some necessary basics that you will need to know. Of those basics, you will need to know that the standard form of the equation of a hyperbola function is always given as y is equals to a over x minus p and then plus q, right? Now, understand that the purpose of a is to determine the wideness and shape of the graph. So how wide or narrow the shape of the hyperbola function will be determined by the value of a, right? But then also, again, the shape. When we speak of the shape, which is the most important function of that a value, is the fact that if our a is greater than 0, meaning that our a is a positive value here, we will find that our hyperbola function will be drawn in the first quadrant and also in the third quadrant, right? So it will occupy the first quadrant and also the third quadrant. So this is that. And then if you find that your a is less than 0, meaning that it's negative, you will then find that your hyperbola function will occupy the second quadrant and also the fourth quadrant. So this is very crucial for you to know, because when it comes to having to draw, this is one thing that they mark, the shape of the graph. So if you get the shape right, then it is most likely that all the other points that you will plot there will be correct, right? So everything depends on the shape of the graph. Now, that's the function of the a there. But then what is p? P is the vertical asymptote, right? So p indicates the vertical asymptote, and the vertical asymptote is always given as an equation. In this case, it will be given as x is equals to p, right? So basically what you do when you want to represent the vertical asymptote is that you always take the denominator, x minus p, and then equate it to 0. So obviously the p value will be a certain value there. Let's say maybe, for example, you have an equation that goes y is equals to 3 over x minus 2 and then plus 5, for example, right? Then if you want to give the equation of the asymptote, this is what you will do. You will say x minus 2 is equals to 0, and then now this will give you x is equals to 2. So that becomes your vertical asymptote as a value like that in an equation. So note that. And then what about q? Q is your horizontal asymptote. Your horizontal asymptote. So also this asymptote will be given as an equation as y is equals to q. Right. So note the difference. When giving the vertical asymptote, it's x is equals to the certain value p, but then when giving the horizontal asymptote, it's y equal to the certain value q. Right. So this is these are the things that you need to know, the necessary basics that you'd have to know before answering any hyperbola function question. So okay, let's proceed. So starting with the lesson, we'll start with determining the equation. So let's say with all these questions I'll be doing here, I'm trying to determine the equation of the hyperbola. So determine the equation of the hyperbola in the form of y is equals to a over x minus p plus q. So I'm trying to find the equation of the hyperbola in this format here, which is the standard form, right? As you can see, what we are given, the given equation here is not in this standard form, right? We have x minus 2 over x plus 1. The standard form says that we must have a value here over x minus p and then plus q. Now, how do we change this to that, right? So basically here, what you need to note is that we always have to focus on the denominator, right? So our purpose here is having to change the denominator. We are guided by the denominator. So we are guided by the denominator. So basically, we are trying to change or manipulate the numerator so that it looks more like the denominator, right? So we have y is equals to x minus 2 over x plus 1. We are trying to write this numerator here in terms of that, right? So what are we going to do? We are going to say, how can we manipulate this x minus 2 so that it has x plus 1 in it? And if we say x plus 1 minus 3, and then over x plus 1, you will agree that 1 minus 3 is still equals to negative 2. So which means mathematically, I haven't changed anything here. My expression still looks, is still giving out the same value there, as in terms of 1 minus 3 is negative 2. So mathematically, I haven't changed anything. But then I just manipulated the equation because I want the expression x plus 1. Right. So what am I going to do at this point? You will realize that we do have a maths rule that says if I have a plus b over c, for example, the law says that I can actually write this terms here in expressed to the same denominator. Right. So I can actually say y is equals to a over c plus b over c. So these two terms here, I have separated them, but then I have actually expressed them to the same denominator because this is a plus b all over c. So that means they share the same denominator. Now, this is what I'm going to do. I'm simply going to take this as one term and then also the negative 3 as another term. So meaning that if I have to break it down like this will become x plus 1 over x plus 1. And the negative 3 over the same denominator, x plus 1. Right. Now, at this point, what have I achieved? If I take x plus 1 over x plus 1, because this is the same expression on the numerator and denominator, we know that they have to divide out. And then when they divide out, they give us 1. So as you know, a over a is equals to 1. B over b is equals to 1. So basically, if you have the same expression on the numerator and denominator, when you divide them out, they give you 1. So this is 1 minus 3 over. Remember this, we cannot be able to divide this one here. But then remember the format that we are trying to reach is this, right? So at this point, we can see that the format is almost similar. All we have to do is just rearrange it to look exactly like that. So we have negative 3 over x plus 1 and then plus 1 over them. So that's how we have it. Negative 3 over x plus 1 plus 1. And then as we can see, the value of a is negative 3. The value of p will be negative 1, considering that we have a minus here. So obviously the p was negative 1, so that we had a positive here. And then your q value is just 1. So if we can just list it out, your a is negative 3. Your p is negative 1, and then your q is positive 1, considering that we are expressing this in that format. Okay, so that's basically how we find the equation of the hyperbola in that format. Now, because the purpose of these lessons are for mastery, let's see another question that is similar to that and see if we can be able to tackle it. Right, so now we have something that looks a bit complicated now. It's y is equals to 2x plus 6 over x plus 2. Again, remember, we are being guided by the denominator. So everything that we are doing here is being guided by the denominator. We are trying to manipulate the numerator so that it looks more like the denominator. Now we have 2x plus 6, of which if we can consider that these two here are common factors, if you factor out 2, you will have x plus 3, right? But then shucks, because now we won't be having something that looks similar to this. Remember, here we only have x plus 2. We are looking for x plus 2 and not x plus 3. So this here would be incorrect, right? So this approach wouldn't cut it for us. Now we need to think strategically or creatively, how can we express this so that it has x plus 2 here? Now let's look at 6. there are certain ways in which we can write 6. We can write 5 plus 1. We can write 3 plus 3. We can write also 4 plus 2. Right. So these are the certain ways in which we can write 6, 5 plus 1, and then we can also have 3 plus 3. We can also have 4 plus 2. Now we are going to choose the one that will be much suitable for this expression that we have here. Now, we do agree that if we can go with 4 plus 2, this will be 2x plus 4 plus 2 over x plus 2. Right. And then if we can just choose to go with this one. So bear with me on this one here. So this is one expression and this is another expression. I now have 2x plus 4 over x plus 2 and then plus 2 over x plus 2. Now you can argue and say, but then we haven't created x plus 2. But if we can just look a bit closer here, remember 2 and 4, they actually have a common factor. And the common factor between 2 and 4 is 2. Right. So meaning we can factor out 2. But then when we factor out 2, look at the magic that we are going to have. When we factor out 2, now we are left with x. And then factoring out 2 from 4, we are left with 2. Now, what have we created here? We have created an expression that looks similar to what we have now. To consider the fact that here we can cancel out, we have this canceling out with that. And then this will give us y is equals to 2 plus 2 over x plus 2. Now we know that you cannot cancel this 2 and 2 here because this is one term here. This is the whole expression. So that means you cannot cancel out with that. But then remember the format that we are trying to have is a over x minus p and then plus q. So that means we need to rearrange this and then we have y 2 over x plus 2 and then plus 2. Right. And then now we can see that it's in the same format. So our a being equal to positive 2, our p, considering this format here, has to be negative 2, and then our q has to be the positive 2 that we are seeing there. Right. So just like that, we have our equation. Okay, so now let's proceed once more. Let's proceed. We now have y is equals to x minus 3 over x minus 2. So this one looks fairly simple, almost similar to the one that we got from the beginning, x minus 3 over x minus 2. Now, again, here we must find a way in which we can write this so that it looks similar to that. So this will just be x minus 2 minus 1. Now, negative 2 minus 1 still gives you negative 3. So I haven't changed anything mathematically, just manipulated. Then x minus 2 over here. At this point, I take this as one expression and then that as another expression. Now I have y is equals to x minus 2 over x minus 2 and then minus 1 over x minus 2. Again, here when I divide these ones out, because it's basically the same expression, I'm going to have 1. So this is y is equals to 1 minus 1 over x minus 2. So to rearrange it so that it's in this format, all I have to do is just swap the positions. It's negative 1 over x minus 2 and then plus 1. Remember, it's a positive. And then just like that, my a value is negative 1. My p value is just equal to 2, positive 2, as we can see here. And then my q value is going to be what? 1. Right. So that's it. Just like that, I have found the equation. I have found the equation. Okay, so let's look at another one. Another one similar to the second one. So we have y is equals to 3x plus 6 over x plus 3. Again, if you look at the fact that 3 and 6, there is a common factor there between 3 and 6, which is 3. If you factor out 3, we are going to have 3 and then x here and then 2. But then looking at our denominator, it's actually x plus 3 and not x plus 2. So now we must think of a way in which we can write the 6 there in terms that we must end up with a 3 there. Okay, so now the 6 can be expressed as 3 plus 3, right? Of which if we have 3 plus 3, we still have a problem here. If we say 3x plus 3, we factor out 3, we are going to have x plus 1, which is not what we are looking for. Now, another way in which we can write 6, remember, you need to be creative when it comes to this. Another way in which we can write 6 is to say 9 minus 3, right? So do not always think of addition. You can also think of subtraction, right? So 9 minus 3 meant to say is still equals to 6. But then how is the 9 going to help us? Check this out. If I have 3x plus 9 minus 3, now I can actually factor out the 3 from 3 and 9. And then this will be 3 and then x. And then if we factor out 3 from 9, we have 3 and then minus 3 like that. But then look at what we have created here, x plus 3, which means it will cancel out with that x plus 3. So this is how we are going to solve this. This is how we are going to solve this. We'll say y is equals to 3x plus 9 minus 3, which we haven't changed anything mathematically. 9 minus 3 is still equal to 6. And then over x plus 3. This is y is equals to 3 bracket x plus 3 and then minus 3 over x plus 3. Now, if I take this as one term here, okay, so this is what I was supposed to do. So if I take this one as one term, this is y is equals to 3x plus 9 and then minus 3 over x plus 3. So this is y is equals to 3 bracket x plus 3 over x plus 3. Then minus 3 over x plus 3. Right. Now at this point here, we will have this and that cancel out. So this is going to be y is equals to 3 minus 3 over x plus 3. And then if we are to rearrange it into the perfect format, this is y is equals to negative 3 over x plus 3 and then plus 3. And then just like that, we know that our a is negative 3. Our p will be a negative 3 as well. And then our q is equals to positive 3. And that's just how we were supposed to solve that. So note how we actually solve these questions right here. So I hope all that makes sense. And then let's now proceed to the next session of the next part of the session. Okay, so now jumping right down to this exercise here, we are given the equation y is equals to 2 over x minus 2 plus 1. And then from this exercise, we'll just be trying to answer these 5 key questions. So I normally call this the 5 key questions of the hyperbola function. And if you were to go to your exam papers, past exam papers, you will find that most of the time you are answering questions around this when it comes to your hyperbola function. So once you can understand these 5 key questions, then it becomes very, very easy to tackle hyperbola functions in the exam. Right. So now, given this equation, they say write down the equations of the asymptote. As we have previously discussed, when it comes to the asymptote, we said that asymptotes are expressed as x is equals to p and y is equals to q, whereby the p is that value there and then the q is that value right there. But then when it comes to this, I said always note that you actually get to this point by taking this and equating it to 0. So if you say x minus 2 equal to 0, and then now you write it as x is equals to 2, that becomes your vertical asymptote. So for number 1, I'm going to have x is equals to 2 as my vertical asymptote, and also y is equals to positive 1. So that's just that, 2 marks in an exam, so they mark that and they mark this. Make sure that you always write them in terms of equations. So even the question will say, write down the equations of the asymptote, as you can see right there. Okay, so number 2 says, determine the x and y intercept. Right, from our linear functions also to our parabola functions, we discussed that every time you are calculating the x-intercept, you always have to make sure that your y is equal to 0. So x-intercept is when y is equals to 0. So all you have to do here is take this expression here on your right-hand side and then equate it to 0. So your y is 0, you just equate it to 0 like that. How do you then solve from here on? One thing that you always have to do is take this value over here, transpose it over to that side. So you have 2 over x minus 2 is equals to negative 1. And then obviously at this point, you need to cross multiply here. This is 2. Okay, so now let me just negative 1 over 1. So let's say I'm cross multiplying like this. So this is negative 1 bracket x minus 2. And then I'm going to cross multiply 2 and 1. So 2 times 1 is just 2. Now, if I multiply here, this is negative 1 times x, it's negative x. Negative 1 times negative 2, it's positive 2, and then it's equals to 2. Now, if I take this and transpose over to that side, that's 2 minus 2, which will give me 0. And dividing both sides by negative 1, x is still equal to 0. Right. So just like that, I now have my x-intercept. In terms of coordinate, this will be 0 is to 0. Now, I need to calculate the y-intercept. Y-intercept is when you make x equal to 0. So basically what you do here, you write this equation as it is, but then where there is x, you substitute by 0. So you have 0 minus 2 and then plus 1. Now you can simply just punch all of this into your calculator, or you can just solve it manually. 2 divided by negative 2 is negative 1 plus 1. And then y is equals to 0. So at this point, we have a rare case whereby our x-intercept and our y-intercept is the same. So we have 0 is to 0 as well. So we have the x-intercept and the y-intercept occurring at the same place, which is the origin. Right. Then number 3 says, give the domain and range of the graph. What are we talking about? What is domain? What is range? We have previously discussed that the domain is a set of all possible x values, right? So all the x values that are applicable right there, they fall into the domain. But remember what an asymptote is. An asymptote is where the graph, the point where the graph does not touch. So this is the point where the graph does not touch. So pardon me for that ugly handwriting there. So domain is a point where the graph does not touch. Remember, in number 1, we stated that our asymptote is x is equals to 2, meaning that all x values are applicable. Remember, these are invalid, and asymptote is an invalid point, right? So this is a point whereby the graph will not touch. Now, if we are to write the domain, we should always say the domain is an x element of real numbers, but we have to exclude the asymptote because we are saying the asymptote is an invalid point. So we write the domain as x element of real numbers where x is not equal to 2. And then we have to write the range as y element of real numbers where y is not equal to that asymptote, which is 1. So we are saying x is equal to 2 and y is equal to 2 are invalid points. So the domain is a set of all possible x values, meant to say. So that means it's x element of real numbers where x is not equal to that asymptote. Range is a set of all possible y values. So it's y element of all real numbers, but y should not be equal to the asymptote. So basically, that's how you write it always. That's how you present the domain, right? Of the domain and range of the parabola, of the hyperbola graph. Okay, nice one. Now, number 4, we are coming to the equation of the axis of symmetry. Now, we have the equation of the axis of symmetry with the positive gradient and also the one with the negative gradient. You need to be in a position whereby you know the difference between the two and how you write them. Right. So, the one with the positive gradient, this is how you're going to write it. I need you to note this. We call this the bus method. So all you have to do is take this here. So the only value that you're not taking is the one for A. So you simply just take the expression like this. That's your equation of the axis of symmetry with the positive gradient. Right. So you will say it's y is equals to x minus 2 and then plus 1, which is going to be y is equals to x. Negative 2 plus 1 is negative 1. So you're just going to leave it like that. You have your correct answer just like that. But then how do you deal with the one that says negative gradient? In your question paper, you'll be asked to write either one of this. So you'll not be asked to write both of them. It's either the positive gradient one or the negative gradient one. Right. So with the negative gradient, what you need to do is you come here, put this expression only, the one that is on the denominator. Understand that. The one that is on the denominator only, you put it inside the bracket and then you have a negative right there. So this is going to be y is equals to negative in bracket x minus 2 and then bracket plus 1. Then when you multiply inside, this is going to be negative x and then a negative and negative, that's positive 2 and then plus 1. So this is y is equals to negative x plus 3. Now you solve it until you cannot do anything further. So from here, we know that x and 3 are not like terms. So that means you have to leave it like that. You have your expression like that. Note that your axis of symmetry is actually a straight line. So the axis of symmetry is a straight line, which is why you can see that both of these equations are in the form of y is equals to mx plus c. So both of these are straight lines. The positive gradient one is a straight line that will go in this direction because it is a positive gradient. So sometimes if they don't want to say, write down the equation of the axis of symmetry with the positive gradient, they will say, write down the equation of the axis of symmetry that is increasing, right? Remember, if it's increasing, that means it has a positive gradient. If it's decreasing, that means it has what? A negative gradient. So also note that if they say axis of symmetry, which is increasing, that means they referring to the one with the positive gradient. They say an axis of symmetry which is decreasing, they're referring to the one with the negative gradient. So the axis of symmetry are straight lines in nature. Okay, so now we are fine with that. So number 5 is to sketch the graph, of course. So we need to know how to sketch the graph. When it comes to sketching the graph, the important things is that you clearly show. So even if they tell you to sketch the graph, they say sketch the graph and clearly show all the intercept with the axis. So clearly show all the intercepts with the axis. And then also clearly show the asymptotes. So the asymptotes. So these are the two most important things. The intercept with the axis, the asymptote. And then number 3, which is, this is what you need to actually note, NB, the shape, right? So you can have the intercept with the axis and the asymptote, but if the shape is not correct, then you are most likely to just get 0 on that. So the shape is the most important one. So understand that if your A is greater than 0, this is the shape that we're expecting. First quadrant and third quadrant. If your A is less than 0 negative, this is the shape that we're expecting. So before you can actually think of anything, make sure that the shape you get it correct, right? So, okay. Now, when you want to sketch, it is advisable that you start with the asymptotes, right? So you start with your vertical asymptote and your horizontal asymptote. So let me just show you the graph that I've already drawn. So the vertical asymptote, so there we go. Just going to have this. So the vertical asymptote is this one. As you can see, it passes through positive 2, right? Remember, we gave the equation as x is equals to 2. So that means it must pass through the x-axis and cross 2, right? So x is equals to 2. The other one was y is equals to 1. So as you can see, the graph is curving here, not touching positive 1. So I was supposed to have the asymptote right here. Supposed to have the asymptote right here. So there we go. That's how we represent the asymptote. So this is how you represent the asymptote. It's y is equals to 1 and then x is equals to 2. So the horizontal asymptote always passes through the y-axis, which is why the equation is y is equals to 1. The vertical asymptote passes through the x-axis, which is why it says x is equals to 2. So that's how you have it, right? Okay, so again, if you think about it, this is in the form of a straight line. Remember, a vertical line always has the equation x is equals to a particular value, and then a horizontal line always has the equation y is equals to a particular value. Right. And then from here, obviously, you need to indicate your intercept. We only had the x and y intercept occurring at the same point here. So that means we're only going to plot there. That's the point 0:0. So as you can see, this one is just floating on its own. Now, you don't just show this one. Remember, it's not a complete hyperbola function if it does not have that one as well. So this one, you just mainly draw it with your free hand. So you just draw this and then join it over here and then use your free hand to draw this one. So when it has these two wings here, it is what we call a hyperbola function, right? So there you go. You have your hyperbola function like that. Now to indicate your axis of symmetry, they don't need you to indicate the axis of symmetry though, but then an axis of symmetry is a line that would actually go and cut the part here if it was a positive gradient, and then the one with the negative gradient would actually pass through that same point here. So basically, the axis of symmetry cuts the graph into two equal halves. So if you can look at it, it's more like if you look at this line here, pretending that it's a mirror, you will see that this part here is actually a mirror image of that one, right? And also, if you are to consider this line here, you will see that if you cut here, this half here is equal to this half right over here. But then the axis of symmetry in grade 12, you will not need to show them. So they only want you to show the asymptote and also the intercept with the axis. So just like this, you are done. Okay, now let's look at another one, right? Remember, we are trying to master here. So let's look at another equation and then try to answer the very same questions. So y is equal to -1 over x minus 1 plus 2. Now, number one says write down the equations of the asymptote. Already we know x minus 1, so we write it as a positive. If it's negative, we write it as a positive. If it's positive, we write it as a negative. So x is equals to 1. But then when it comes to the vertical asymptote, simply write it as it is. If it was a negative, I was just going to write it as a negative. If it's positive, you simply take it as a positive. So y is equals to 2. So this is our number one. Now, determine the x and y intercept. X intercept, we start by making y 0. So it's going to be -1 over x minus 1 plus 2 equal to 0. First thing is we take this and transpose it over to that side. And then it's -2. Then we're going to write -2 over 1 so that we can cross multiply now. Let's cross multiply. We're going to have -2 bracket x minus 1 is equals to -1 times -1 is negative. -1 times +1 mean to say is -1. Now if we multiply inside, that's -2x. And then this multiplied by that, that's +2, and then it's equals to -1. We can take the 2 and transpose it over to this side. It's -2x is equals to -3. If we say -1 minus 2, it's -3. Dividing both sides by -2, then our x is equals to 3 over 2, which 3 over 2 can be simplified to 1.5 if we are writing it in decimals, right? Okay, nice. If we have that, let's now calculate the y-intercept. So for the y-intercept, we have to make x equal to 0. Then it's just simple, y is equals to -1. Where there is x, I put 0, and then plus 2. Now, if we punch this into the calculator or manually do it, -1 divided by -1, it's +1 plus 2. Then y is equals to 3. So in coordinate form, we have 0 is to 3. Here in coordinate form, we have 3 over 2 is to 0, or simply 1.5 is to 0, right? So just like that, we have the x and y intercept, right? So it's just easy to calculate. The y-intercept is the easiest to calculate. The x-intercept, you only just need to mind the strategy and the format in which we calculate that, the steps, right? So first, you take the constant, transpose it over to the other side, then you cross multiply, and then you solve for your x. Okay, number 3 now says give the domain and range of the graph. Domain, a set of all possible x values. So remember with the domain x element of real numbers, where x is not equal to the asymptote. So you always have to exclude the asymptote. So where x is not equal to +1, because our asymptote was x is equals to 1. And then the other asymptote was y is equals to 2, which will now speak for the range. The range, we're going to write it as y element of real numbers, where y should not be equals to the asymptote. So y is not equals to 2. So that's it, guys. It's pretty straightforward and simple. Do not confuse it. And then when it goes to number 4 now, it says write the equation of the axis of symmetry with a positive and negative gradient. So for the sake of practice, we're just going to do both of them, right? But then we know in an exam, you'll only have to write one of this. So positive gradient, we said the bus method means that we take this, right? We take this here. We take this. And then we are going to say y is equals to x minus 1, then plus 2. And then y is equals to x plus +1. So we are done with the one with the positive gradient. And then what about the one with the negative gradient? So negative gradient, again, we take that, but then we are supposed to put this inside the bracket and have a negative outside here. So this is y is equals to negative x minus 1 and then plus 2. Note that this negative only affects what we have here on the denominator and not the constant value here. So this is negative x and then +1, then plus 2. So this is y is equals to negative x and then plus 3. And then just like that, we have the axis of symmetry, both that have a positive gradient and a negative gradient. Right. Then sketch, again, for the sketch, you need your intercepts. Clearly show all the intercepts with the axis and clearly show all the asymptotes. And then also know the shape, right? Considering this one, A is less than 0, so we know the shape is second quadrant and fourth quadrant. So, okay, now this is how we're going to have it. So let's have the one that is already drawn here. Okay. So to indicate this, we are going to have this one here crossing over like this, and then is the vertical asymptote. And then we have the horizontal asymptote passing through at 2, right? Now, once you have the asymptote, the quadrant now changes, right? This is the first quadrant like this. So the reason why I say always draw the asymptote first is because your asymptotes now, they determine the new Cartesian plane that you are drawing, right? So this is now the first quadrant. This is now the second quadrant. This is now the third quadrant. And this is now the fourth quadrant. So that's what you need to understand there. So first indicate your asymptotes so that you now have a new placement of the quadrant. Now we can see that because this is negative, it's now on the second quadrant and on the fourth quadrant. Second quadrant and the fourth quadrant. And then again, once you have clearly shown that, so you can indicate here that this is your y is equals to 2, and then right here you have your x is equals to 1. But then your intercept, remember we did calculate the intercept. We had calculated that the intercept for your, what you call, your y-intercept, your x-intercept was 3/2, which was 1.5. Now looking at this, we can see this is 0, 0.51, 1.5 here, and then followed by 2. Right, so that's the 1.5, but then we calculated here and we found that it was 3. So looking at this, it's 0, 1, 2, 3, 4, right? So the point in here is 3, and then the point in here is 1.5. So we have clearly shown, all we have to do in order to clearly show, when they say clearly show, it means that just come here and plot. right? Plot the point so that it is visible to our eyes that you have calculated the x-intercept and the y-intercept. So you just simply plot this. Okay, and then just like that, that's how you are supposed to sketch. So first start with the asymptote and then ask yourself, how is the shape supposed to be? So it's negative, it's supposed to be on the second and the fourth quadrant. And then what are your intercepts? So simply plot your intercepts there and just have your smooth curve. So you don't do this with a ruler, just freehand and then smooth curve. Okay, so let's proceed now. We have another one. It says y is equals to negative 3 over x plus 2 and then minus 5. Number one says write down the equation of the asymptote. We already know at this point. So x will be equals to, remember we have a positive, so it's supposed to be negative 2. And then y is going to be, I'm simply going to take it exactly as it is, negative 5. Right. And then to determine the x and y intercept, so x-intercept, remember, we make y equal to 0. So we are going to have negative 3 over x plus 2, and then minus 5 is equals to 0. The process is always the same. Take this, transpose it over to that side. Negative 3 over x plus 2 is equals to positive 5. And then you say 5 over 1. Then now you can cross multiply here. So 5 multiplied by this, it's 5 bracket x plus 2. And then if you multiply that, it's negative 3. 1 times negative 3. Now you can multiply inside by this 5. That's 5x. And then plus 10 is equals to negative 3. So it's going to be 5x is equals to negative 3 minus 10. That's negative 13. Divide both sides by 5. Your x is going to be negative 13 over 5, which let's see what we get from the calculator. I think it's negative 2 point something. So negative, yes, negative 2.6, right? So negative 2.6. So that means negative 13 over 5 is 0. Now, what about the y-intercept? Y-intercept, you make x 0. So this one is fairly simple to calculate. Negative 3 and then 0 plus 2 here, then minus 5. You can simply just punch all of this into your calculator. Negative 3 over 0 plus 2, and then minus 5. That's going to give us what? Negative 13 over 2, of which negative 13 over 2 can be written as negative 6.5. So the reason I'm changing that into decimal is because that's what I will need when it comes to sketching the graph. Remember, there is no way in which I can find negative 13 over 2 in a Cartesian plane. So I need to actually have it in decimal so that I can be able to plot it. Okay, so I have 0 is 2, negative 6.5. And then here I have a negative 2.6 is to 0. Okay. So x and y intercept, we are done. So do not always expect integer values. It is possible that you have fractions. It is possible that you have decimals. Then a domain. So whenever we want the domain and range, we must always go back to our asymptote. So x is equals to negative 2 and y is equals to negative 5, because we know the domain should be x element of real numbers, where our x should not be equals to the asymptote negative 2. And then our range should be y element of real numbers, where our y should not be equals to the asymptote negative 5. So that's it with your domain and range. Okay, then we have number 4. It says write the equations of the axis of symmetry with a positive and negative gradient. Right. So how do we do it? Again, our bus method, we simply take this here. Take this. Right. And then starting with the one with the positive gradient. So positive gradient. And then this side we have negative gradient. Okay. So positive gradient, we are just simply going to have y is equals to x plus 2, then minus 5, which will then simplify to x minus 3 because 2 minus 5 is negative 3. And then for this one here, negative gradient, we're going to have y is equals to, remember, this in brackets and then the negative over here, negative x plus 2 and then minus 5. So this is y is equals to negative x minus 2 and then minus 5. So y is equals to negative x minus 7. Right. So we have the axis of symmetry with the positive gradient and the one with the negative gradient. So I hope now it makes sense. You are able to calculate this. So once you master these 5 questions, guys, I'm telling you, you won't have any problem solving the hyperbola graph questions. Then sketch the graph. Remember, we must clearly show all the intercepts. We must clearly show all the asymptotes. And then we must also be mindful of the shape, right? Let's be mindful of the shape. So 3 things that you need to be aware of: intercepts, x and y intercept, asymptote, your vertical and your horizontal asymptote, and the shape, right? Is it on the first quadrant and third quadrant, or on the second quadrant and fourth quadrant? Based on our value of A, we can tell that it's second and fourth quadrant. So let's have our sketch. So our sketch here, remember, for the x-intercept, we had something like negative 2.6, of which it does make sense considering that here we need to have negative 2.5. So the fact that it is just a little bit far out, a little bit to the side from that negative 2.5, it actually indicates that that could be 2.6. Remember, it's just us having to predict the value there, right? And then we also calculated the other one. It was negative 6.5. So considering that we must have 7 here, then obviously in between we can have the negative 6.5, which is 6.5. So there we go. So clearly indicate the intercept, and then let's clearly indicate all the asymptotes. So we have this asymptote here, the vertical asymptote, and we should also have the horizontal asymptote at negative 5. So there we go. As we can see, it's not touching the graph at any point. So then we indicate this is our y is equals to negative 5, and then this is our x is equals to negative 2. So we've clearly shown all the intercepts, and we've clearly shown all the asymptotes. Now again, note this. This here becomes, remember, once we place the asymptotes, this is now the first quadrant, second quadrant, third quadrant, and fourth quadrant. So the asymptote actually give out a new set of quadrants, right? So it's in the second quadrant and also on the fourth quadrant. Second quadrant. So this is now the first quadrant, second quadrant, third quadrant, and then the fourth quadrant. So second quadrant and fourth quadrant, because our A is negative. Okay, so let's proceed. We have this one. It says y is equals to 3 over x plus 2 minus 1. And then number 1 says write down the equation of the asymptotes. So again, x is equals to, so x is equals to negative 2, and then y is equals to negative 1. Determine the x and y intercept. X-intercept, make y 0. Guys, we are basically doing one and the same thing throughout, right? So this is for master, guys. Do not be bored when I do this, because all I'm just trying to do is make sure that when you walk into the exam, it's already on your fingertips. It should not be on your head. It should be on your fingertips. You should not even think about this. You should just write it quick, and then you are done. So this is a cross multiply here, x plus 2 times 1. It's going to be x plus 2. And then 3 multiplied by 1, it's 3. Then you can transpose the 2 over there. It's going to be 3 minus 2, which is going to give you 1. So your x-intercept is 1 is to 0. Now, y-intercept, you make x 0. So you're just going to say y is equals to 3 over 0 plus 2, and then minus 1. Then at this point, you need umshini ibalo. So 3 over 0 plus 2, and then minus 1. So it's going to give us 1 over 2. 1 over 2 is half, 0.5. So you have 0 is to 1 over 2, or simply 0 is to 0.5, right? So that you'll be able to sketch that. Okay, dominant range. When it comes to dominant range, remember you must always keep your asymptotes there, so that you can say domain is x element of real numbers, where your x should not be equals to -2. And your range is y, shucks. So your range is y element of real numbers, where your y is not equal to -1. So that's it. Just exclude the asymptote. Okay, nice. So this was your number 3. Number 4 now, write the equations of the axis of symmetry with a positive gradient and a negative gradient, right? So this is basically how you practice, guys. Make sure that you do the very same questions over and over again, right? Over and over again. Practice makes perfect. Even if you were in a dance crew or maybe in a choir, what you normally do when you are practicing is just repeating the same thing over and over again until now it is part of your system, right? So until now it's just an involuntary act and you are no longer thinking about it. So if you can see those the people that are dancing there on those dance shows, or maybe on Americans Got Talent, they just practice that over and over again until they were perfect. That's what you do with math. Basically the same thing, guys. Practice makes perfect. So this is the one with the positive gradient. The one with the positive gradient, you'll say y is equals to x plus 2 and then minus 1, which is going to give us y is equals to x plus 1. 2 minus 1 is 1. And then for the one with the negative gradient, you have to remember that you come here, only the denominator inside the bracket and then negative outside. So y is equals to negative bracket x plus 2 and then minus 1. So this is y is equals to negative x and then negative 2 minus 1. So y is equals to negative x minus 3. And then voila, that's it. So you are done with that. So you have the one with the positive gradient and the one with the negative gradient. Now we come to sketching. Sketching, the most important things, once again, is that you know the intercepts with the axis. Intercepts with the axis, and then you clearly show all the asymptotes. And then also, again, you make sure that you know the shape, right? So based on the fact that our A is greater than 0, it's positive, we know that it will be on the first quadrant and the third quadrant. But then in order to determine those quadrants, you need to first sketch the asymptotes, right? So the asymptotes, they give a new meaning to those quadrants. Okay, so there we go. Sketching our asymptotes first. So we have this vertical asymptote here. Vertical asymptote crossing at -2, and then a horizontal asymptote crossing at -1. So there we go there. So -1. Make sure that it does not touch with those curves, right? So we can indicate this is y is equals to -1. This is x is equals to -2. And then now to show our intercepts, remember we had this x-intercept here. It was 1:0. So as we can see here, 0, 1, 2. So this is 1:0. And then we also had another one here, which was 0.5. So y was equals to half, which is 0.5. And as we can see here, this is 0, 1. So it's in between 0 and 1. It must be 0.5. So you just indicate it. So let me just have it in red so that we can clearly see it, right? So clearly show all the intercept with the axis. We have clearly shown like this, and then we have also shown the asymptotes. Then voila, you have your curve nicely like that, and then it's curving nicely. And then this one, since it's not touching anything here, you just have to draw it with your free hand here. Just make sure that it curves nicely like that, and then you have a complete hyperbola function. Now, as you can see, this whole part is the first quadrant. This whole part here is the second quadrant. This part here is the third quadrant, and that part over here is the fourth quadrant. So it's in the first and the third quadrant. So that's it, guys. Basically, that's all we do when we solve these questions here. So make sure, guys, that you go back to these questions, practice them as many times as possible. Try to find also other similar questions from your textbook, and then make sure that you just master this topic right here, right? But then that's all we do when we practice questions. Just do that one thing over and over again until now it becomes part of you. With all that being said, guys, catch you on the next episode. Ciao.